Kia ora Year 12. This is question 7 from this year's school exam. It's a good example of a hypothesis test for a Poisson random variable, and there are some nice questions in here about type 1 and type 2 errors. Now, when you're working with a normal distribution, the type 1 error is basically the level that you're given. But when you've got a Poisson or a binomial problem, it's a little bit more precise than that. So let's just start by reading through the question. We've got a hospital patient with a white blood cell count, and that's got a Poisson distribution. So remember that if it's got a Poisson distribution, the values it can take on are 0, 1, 2, 3, and so on. However, the mean, or the lambda for that Poisson, doesn't have to be an integer, and that's what we've got going on here. So on average, before undergoing treatment, the patient had a mean white blood cell count of 5.2. And after the treatment, we want to see whether the mean white blood cell count has decreased, and we're going to use a 10% significance level. So first we have to explain what's meant by a type 1 error, but we have to do that in the context of the question. And then we have to find the probability that the test gives you a type 1 error. So a really common mistake to make here is to go, well, hey, it's given to us in the question, it's going to be 10%. But it's not, right? It's going to be the probability that we wrongly reject the null hypothesis. Then we have to go on and do the hypothesis test, and we're told that what the patient has after the treatment is 2. So if x equals 2, are we going to reject or accept the null hypothesis? Lastly, we have to find the probability of a type 2 error, and to do that we have to be given the true value of the mean white blood cell count after treatment. Okay, so that's a long intro on purpose, because these concepts need quite a bit of thinking about when you first see them. So the first thing to notice here is that we have to give our type 1 error in context. So a type 1 error is when we wrongly reject H0. So it's fine to say that, but that's not putting it into context. So what we're doing when we do this test is we've got H0, which is that lambda is equal to 5.2 after the treatment, and H1 is that it's gone down, so lambda is less than 5.2. So wrongly rejecting H0 means that we're concluding that H1 is now true. So in simple English, what that means is we are concluding that the white blood cell count has dropped or decreased when it really is still 5.2. Right, now the next thing that we've got to do is to find the probability that the test results in a type 1 error. So what we have to work out here is when are we going to reject the null hypothesis. So let's work our way up. We're going to reject, let's see, in the most extreme case where the white blood cell count is 0, which would be terrible, we'd have e to the negative 5.2. So that gives me this extremely low value. So we're going to reject if x equals 0. Now what about if x is equal to 1? Well, if x is equal to 1, we can find the probability using the recursion relationship. I'm not going to review that completely, I'm just going to use that here. We did that much earlier when we first looked at the Poisson. So the probability of x equaling 1 is equal to that, but that's not what I'm looking for. I'm looking for, if I see the blood cell number being 1, I'm finding the probability that it's 1 or even lower, right? So here, the probability that x is 1 or lower is equal to this number plus this number. So that's 0.0342. And I'm asking myself, is the probability of getting 1 or lower below my significance level? So it's less than 0.1, so we'll reject here. Now what about if we get a white blood cell count number of 2? Well, the probability of getting exactly 2 is this. And if you work that through, you'll get 0.074, 584. So if I get 2, I say the probability of getting 2 or something even weirder is equal to 0.1088. Now you can see that here, this is greater than 0.1, so we don't reject if x is equal to 2, because we say the chances of seeing 2 or something stranger is more than 10%, and we're trying to limit my type 1 error to 10% at worst. So when do we reject? Well, we reject h0 when x is equal to 0 or 1. And the probability of that happening when lambda is 5.2 is what we just figured out. It's equal to 0.0342. So this is my type 1 error. Now, that seemed pretty long and slow, but if you do another example, you'll get into this pattern really easily. And it's the same when you've got a binomial distribution. So let's go back to the question and see if we've answered it properly. The first bit. Okay, so we had to say what a type 1 error is, and then we had to find this probability. Now, the next bit is easy because of all that work that we've done. Given that the measured value of the white blood cell count after the treatment is 2, carry out the test. Well, we've already written down the hypotheses, right? So there they are. So what do I have to say now? Well, I think I'm going to write them down again. So we're going to reject if x is less than or equal to 1, but we've got x equals 2, so we don't reject h0. And as I've said in class, in the Cambridge schedules and textbook, we simply say that we're going to accept h0, right? We haven't got enough evidence to conclude that the white blood cell count is down. So conclude that lambda is equal to 5.2. Okay, so you can see when we've got a Poisson question, we have to do this using a rejection region. Now the last part of the question is to find the type 2 error, right? And a type 2 error is where we don't reject the null hypothesis, even though it's actually wrong. And to figure this out, we have to be given the true value of lambda. So this last bit of the question goes like this. So a type 2 error is equal to the probability that we don't reject h0, given that lambda is equal to 4.1. You can see that we've worked out carefully my rejection region. So my not rejection region, don't reject if x is greater than or equal to 2. So the probability that x is greater than or equal to 2, we have to find by working with the low end of the distribution. It's 1 minus the probability that x is 1 or lower. And that's for a Poisson with a lambda of 4.1 now, not the 5.2 in the hypothesis testing part. So this is equal to 1 minus this. And that works out to be 0.9155. So you can see that this is a huge number, right? Because my lambda value is below 5.2, but not massively below 5.2. So the chances that I don't reject are really, really high. And as I've said in class, that's a pretty common setup with hypothesis testing. So we try to control the type 1 error, but the tighter we get on the type 1 error, the more we have a type 2 error popping up. So that's all for this video. There are some really good practice questions on those in the Cambridge textbook, and they come up quite often. Right, so just be careful that you can find a type 1 error for both a Poisson and a binomial situation, and email me if you've got any more questions like this one.